lecture of functional analysis, I will be doing closed graph theorem. Okay, so let me start. They can ask you all in the exam for state and prove closed graph theorem. Okay, state and prove closed graph theorem. So statement is here: let x and y be a Banach space and T be a linear transformation from x onto y. Then T is continuous mapping if and only if GT is closed. Okay, and GT is what? Nothing but graph of T. It is okay. Now this is the statement from where it is. Yeah, this is the entire statement. Now next is the proof. Okay, let us start with the proof. If T is a continuous mapping of a topological space X into Hausdorff space Y, then graph of T is closed subset of X cross Y. Okay. Now let X1 be the space X renormed by norm of X. Now this X1, let it be space X. Okay, renormed by norm of X is equal to norm of X plus norm of Tx. T of X. Okay. Then X1 is a normed space. Now, norm of T of X is less than or equal to norm of X plus norm of Tx. And norm of X plus norm of Tx is nothing but norm of X, right? Now, this implies what? T is bounded, which implies nothing but T is continuous, has a mapping of X1 cross Y. So, the identity mapping I of X1 onto X is continuous. That is, I of X is equal to norm of X. Now this is less than or equal to what? Norm of X plus norm of T of X, which is equal to nothing but norm of X. Just put this in the bracket, okay? Now which is bounded and hence continuous. Now what we have to do is, if we can show that X1 is complete, then by using Banach theorem, this mapping is a homomorphism. Hence this proof is complete. So we need to show that X1 is complete. And if we show that X1 is complete, then the proof is done. Okay. Now, to show that X1 is complete, what we need to do is that Xn be the sequence in X. Okay. For epsilon greater than 0. This is X. Okay. I hope you all can see this clearly. In X. Now, okay. For epsilon greater than 0, the definition of the Cauchy sequence, okay, that exists and not belonging to natural, such that norm of xn minus xm tends to 0, has mn tends to infinity. So has this tends to 0, has m comma n tends to infinity. Okay, this is the statement from the Cauchy sequence, so definition. Now this implies what? Now what you all have to do? Have you seen norm of X is equal to norm of X plus norm of T of X? So similar way you have to do like this way only. Norm of Xn minus Xm plus norm of T of Xn minus Xm tends to 0. Now this tends to 0, has m comma n tends to infinity. Now this implies what? This you all write it as it is, norm of Xn minus Xm plus then norm of T of Xn minus T of Xm tends to 0. Now this tends to 0, has m comma n tends to infinity. Therefore you all can say that sequence Xn and T of Xn are Cauchy sequence in X and Y. Now since you all know that X and Y are the Banach spaces, okay, in the statement only we have said somewhere here X and Y are the Banach spaces. Let X and Y be the Banach spaces. Then again we have said it over here that then graph of, okay, sorry, over there only X and Y are the Banach spaces. Okay, so that's what you'll have to do over here. Okay, since X and Y are Banach spaces, therefore there exist X and Y belonging to capital X and Y, capital only, okay, such that norm of Xn minus X tends to 0 and norm of T of Xn minus Y tends to 0, has n tends to infinity. Now this norm will tend to 0 and this norm will tend to 0, has n tends to infinity. Next is what? Okay, now GT is closed in X cross Y. Now x comma y belongs to gt, okay, comma is there, okay, over here. Now therefore t of x is equal to y. Also xn minus norm of xn minus x is equal to what? Like you all know, like what we have done for norm of x. Wait, let me use some other color over here. You all know, right? Norm of x is equal to norm of x plus norm of tx, right? See, similar way also what you all have to do, norm of xn minus x is equal to same thing we have written for norm of x is equal to norm of x, right? So same thing you all have written norm of xn minus x plus norm of t of x it was, right? Now here it is what, xn minus x. Like that way you all have to do, okay? Now this is equal to norm of xn minus x plus this is norm of t of xn minus t of x, okay, this. Then this is equal to nothing but norm of xn minus x plus norm of t of xn minus y, because what is tx is equal to y, okay, which you'll have to place it over here. Now this tends to 0 as n tends to infinity, therefore x1 is complete. So with this I'm done with today's lecture and thanks for watching.